Okay, so I'm going to go over your study guide for the Math for Logs test. So remember, your study guide is going to be very similar to the questions you'll see on the test. And then you can always, if you're having trouble with any specific topic, you can always go back and rewatch the video, look at those notes, do some more problems before you take your actual test. Okay, so first topic, graphing exponential and logarithmic functions. So what I want you to do is I want you to pause the video and I want you to graph these either in Desmos or the handheld calculator and sketch a little graph before we talk about the characteristics. So do that in 1, 2, 3. Okay, so it should be very easy for you to sketch some graphs and then you just look at it. So the domain is how far left and right it goes. It keeps going left forever and right forever, so negative infinity to infinity. The range is how far down it goes and how far up it goes. So it does go down forever, but then it kind of stops once you get to 4. It doesn't actually reach 4, so we'll say from negative infinity to 4, and we'll put a parentheses because we don't want it to equal 4. The y-intercept is where it hits the y-axis. It hits at 0, 1, and it does have an asymptote because you have a plus 4, so our asymptote will be y equals 4. So remember, that's that invisible line. That's why the graph is getting close to 4, but it never actually touches it. So when we're talking about increasing, remember that's reading the graph from left to right. So our graph actually increases the entire time, which means it doesn't decrease. Our end behavior, remember, this is just, we're telling what the left side and what the right side are doing. So the left side is going to negative infinity because it's going down forever, down. And then the right side is just getting closer and closer to 4. So the way we write that in not interval notation, in symbolic form is as x approaches negative infinity, that means the left side, f of x is going down, so approaches negative infinity. If we want to say the right side of the graph, we say as x approaches positive infinity, f of x, the graph is going to 4, so approaches 4. So that's how you do those key characteristics. If you look at the second one, the domain is the same thing, negative infinity to positive infinity. The range is different. It's never going to go below negative 5. So I'm going to say, it goes to negative 5, and then we go all the way up to positive infinity. My y-intercept, I'm going to round a little bit. I'm going to say it hits a negative 4.91. And then because you have that minus 5 at the very end, that means my asymptote is at y equals negative 5. So that's that invisible line that the graph gets close to, but it never actually touches. So with this one, reading from left to right, it increases the entire time, which means it does not decrease. And then end behavior. So this is my left side, this is my right side, and I'm just going to tell what it does. The left side is getting closer and closer to negative 5. And the right side is going up forever. So here's what I would write. As x approaches negative infinity, the left side of the graph, f of x approaches negative 5. It gets closer and closer to negative 5. As x approaches positive infinity, the right side of the graph, f of x goes up forever, so approaches positive infinity. Okay, so I want you to pause the video and I want you to sketch this graph. Do that in 1, 2, 3. Okay, so this one, domain, it never goes to negative 4. So I'm going to say it starts at negative 4 and then it goes to the right forever. The range, it does go down forever and it goes up forever, so negative infinity to positive infinity. It hits the x-intercept at about 5, 0. My graph is off because I drew really fast. And this time, because you're talking about a log, since there's a plus 4, so you can kind of see it on the graph. This would be a line, it hits the x-axis, so this is going to be x equals negative 4. So my asymptote does x equals negative 4. Alright, it is increasing from, I'm going to say it starts at negative 4 and goes to infinity. I can't say it's increasing the entire time. I mean, if you said it wasn't from negative infinity to infinity, I would probably count that on a test. So decreasing in none, and then we tell the end behavior. So here's my left side. It's definitely going down. and then this is my right side. And it's getting closer and closer to, I would say, infinity, because it's gonna go up forever. So here's what I would say. As x goes to negative infinity, f of x goes down to negative infinity. As x approaches positive infinity, the right side, f of x goes to positive infinity. Alright. So now let's look at evaluating some logarithms. The first thing we're going to do is we're just going to rewrite the equation in exponential form. So here's my base, here's what I'm taking the log of, and here's my answer. So remember, I write the base of the log, 3. What the answer was becomes my exponent, and then what I was taking the log of becomes my answer. So it would be 3 to the 4th equals 81. Next one the same way. The base of the log, which is 1/2. Negative 5 becomes my exponent, and 32 becomes my answer. Alright, this last one's a little different, because remember, in order to get rid of an ln, you would do an e. So if I did this, it's kind of like the base of the log would be e, and then 8 is what I'm taking the log of, 2.08 would be my answer. So it works the same way. E was the base of the log, so E would be my base of my exponent. 2.08 would become my new exponent, and 8 would be my answer. And if it helps you to color code, then make sure you either get a paper copy of the test, or you print it off, or you do it on your own paper and you're using those colors just like we are here. Alright, so now we're going to write it in exponential form. So I'm going to circle my bases in blue. I'm going to circle my exponents in red. And I'm going to circle the answers in yellow. And now we're just going to do the complete opposite of what we did. So the base of the exponent is 4. That'll be the base of my log. Okay, so remember, oh, I should have done this like this. Anytime we write it in log form, we have to write the actual word log. So let me go ahead and do that, save time. And now I'm going to write my bases. So the base of the exponent is 4, the base of the log is 4. The base is e, the base is 10. The answer by itself is what I would be taking the log of. And now it would equal my exponent. So 7/2, 4, and 4. The only other thing I want you to notice is number 11. Since it's an E, we really should just write it like this. This is how I would see it on the test. And then number 12, remember, if it has a base of 10, you don't have to write the base. So if you saw this on the test, that would also be the correct answer. So just equivalent forms. If you don't see the answer, don't freak out. It just may be a little different than what you were expecting. Alright, and then the last one, we're just going to evaluate. So this is really easy. All you got to do is plug it into your calculator. You can either use Desmos or you can use an actual handheld calculator. The first one is 0. The second one, -4. 15 and 16 have decimal answers, so use at least 2 decimal places, 3 decimal places. I'm going to use 4. If I have you type in an answer, I'll tell you how many decimal places to round it to, so there won't be any confusion. Alright. Then we also did properties of logarithms. So we condensed and we expand. So remember, condense means making it smaller. You would only have the word log written once. And expand means to expand it, so you make it bigger. Okay, so for number 17, remember that anytime you see a number in front of the word log, we're going to rewrite that as an exponent. Okay, so I'm going to rewrite what we have so far. So the log base 3 x to the 4th minus log base 3 y squared. Okay, and then because we have a minus sign, remember we can bring together subtraction by dividing. So both of these have log base 3, so I only need to write it one time. X to the 4th is first, so it's going to go on top. Y squared is second, so it goes on bottom. So that's what my answer would look like. Number 18, anytime you see a number in front of log, you're going to write that as an exponent. So notice this 1/3 is in front of a parentheses, so I have to distribute to everything in the parentheses. Alright, so let me write what we have so far. So log base 7, 64 to the 1/3 power, plus 2 log base 7, 27 to the 1/3 power. Alright, so notice there's also another one, so we can move that one as well. So we have log base 7, 64 to the 1/3, plus log base 7, 27 to the 1/3, and then squared. Alright, and now we're gonna condense this. Alright, so 64 to the 1/3 is 4, so I'm going to just write 4 plus log base 7, 27 to the 1/3 to the second power is actually 36, so I'm going to just write 36. Alright, so I'm going to erase this so I have more room. You can pause the video if you need to. Not 36, sorry, I typed that in my calculator wrong. That's an actual 9. There we go, that's better. So now we still haven't condensed it because we have the word log written twice. So because this is being added, remember you can bring it together addition by multiplying, and we're going to multiply the two things we're taking the log of. So I'm going to write log base 7 only once, and then 4 times 9 is 36. So that is my answer. Alright, number 19. Same thing, even though it's a natural log, anytime there's a number, I'm going to move it to an exponent. I'm only going to put it to the 64 and the k because that's where it's in front of that in parentheses. So here's what we got. Alright, and then we have some other exponents that we can move. So let me write what we have so far. 64 to the 1/2 plus natural log k to the 1/2, and then to the 5th minus natural log m to the 4th. Okay, so I'm going to erase this just so I have some extra room. Tell you what, let's just go ahead and condense it. So 64 to the 1/2 power is 8, so I'm just going to write 8 plus natural log. So we have a k to the 1/2 and also the 5th power. Remember, that's when you multiply. So 1/2 times 5 is 5/2 minus natural log m to the 4th. Alright, so now I'm going to erase just so I have some extra room. Okay, so because we have a plus sign, we can bring that together by multiplying. So I'd have natural log 8 times k to the 5/2. And then because we are subtracting, I'm going to divide that. So m to the 4th. Alright, the other thing I want to caution you on is sometimes they'll put it in equivalent forms. So I'm going to write this over here. This is from Math 2. You probably don't remember it, and that's completely fine. So we would have built like a little house on top. I don't know if you remember that. And then remember, you're talking about a square root. That was super cheesy, but here's what you would do. So the top of the fraction, why did I do different colors? That is so annoying. The top of the fraction would go inside the radical, so I put the 5 right here, and then the bottom of the fraction goes outside the radical. So 5/2 is the same thing as the square root of k to the 5th. So on an answer choice, if you saw 8 square root k squared over m to the 4th, I just need you to understand that those are the exact same answer. So if you did the first answer, don't freak out if you don't see the second one. You just might be looking for an equivalent form. Okay. So next one, same thing. I'm going to move that 2 to this parenthesis, and I'm going to write what we have left. And then because we are adding, we can bring that together by multiplication. Alright, so now we'll just have to actually multiply all of this together. So remember, whenever you have a parenthesis squared, that means you write it twice. So I would distribute, or I would FOIL, and I would get x squared minus 8x plus 16. And then I need to multiply all of that by 3x. Get my like terms together. So I'm going to assume you can do this because you're in Math 4 by now. Alright, so this should be your answer. So I'm going to erase this and I'm going to show you what your final answer will look like. Alright, so that's what you're looking for. Alright, so for 21 and 22, we're going to expand. So we're going to break it apart as much as possible. Okay, so the first thing I need you to see, and it's going back to stuff we did in Math 2, this is a square, and there really isn't an exponent on this as an understood 1. So 4x minus 5 is the same thing as being to the 1/3 power. So when you see that in a radical, just remember that this is the same thing. Okay, so now what I can do is, because I have an exponent, I can move it to the front of the word log. So 1/3 log base 2 4x minus 5. So that would be my answer. Okay, so for the next one, let me show you all the little things that are being multiplied. So the 3, the a to the 7, the c are all being multiplied. So I could break those apart by addition. Okay, and then you were dividing by 5. So remember, you can get rid of division by doing subtraction. 4, 5. And then anytime you see an exponent, you would just move that to the very beginning. So my answer would be log base 4, 3, plus 7 log base 4a plus log base 4c minus log base 4, 5. Alright, moving on. So let's talk about solving some logarithms. So for this one, the logs are the same on both sides, so they can cancel out. So I'd have 3x squared plus 4x equals 2x squared plus 12. I want to get my like terms together, so I'm going to move this over here. So I would have x squared plus 4x equals 12. I should recognize this is a quadratic. Quadratics need to equal 0, so I'm going to move the 12 over. And now, in order to solve a quadratic, remember, I want you to graph it in Desmos and tell me where it hits the x-axis. It hits at -6, and it also hits at 2. You would want to check these for extraneous solutions, but both of these work, so both of them are an answer. Okay, so for 26, I need to combine these two logs because I want to condense them as much as possible. So to get rid of, well, to condense and to get rid of subtraction, we're going to divide. So this would actually be log base 9, 12 divided by k minus 5. Alright, so now, sorry, should have had my phone turned off. Alright, so now the logs are the same. I can cancel them out. So I have 12 over x minus 5 equals x minus 5. K minus 5 equals k plus 6. So I need to get rid of this division, so I'm going to multiply it to the other side. So I have 12 equals k plus 6, k minus 5. I have to distribute all of that together. You should know how to distribute by now. This is a quadratic. I want all quadratics to equal 0, so I'm going to move the 12 over. So let's see, 42. And then I want you to solve all quadratics by graphing them and telling me where it hits the x-axis. So it hits at -7, and it also hits at 6. When you plug this in, this one does not work. You only have one answer at k equals 6. Alright, so for 27, I need to condense the logs as much as possible. Actually, you know what I would do, since y'all are not great at math? Some of you, not all of you. I'm going to go ahead and put this in my calculator and get a number. And then I would divide both sides by 1/2. I would convert it to exponential form. So the base of the log, this becomes the new exponent, this becomes the answer. So I'm going to put the left side in my calculator. I'm going to add 9 to both sides, so 45. And then I'm going to divide both sides by 5. I'm going to do number 28 the same way, just because there's a lot of numbers, so it's kind of easier. So log base 8, 7 minus 5w equals, all right, 5/3. Then I'm going to put it in exponential form. 32 equals 7 minus 5w. I'm going to subtract 7 on both sides. 25 equals negative 5w, and then I'm going to divide both sides by negative 5, so x equals negative 5. Don't forget, if you're multiple choice questions, you can plug in the answer choices and figure out the answer, so don't freak out on me. Okay, moving on. Let's solve these really quickly. Okay, so you can go back through the notes and watch how we did this, or you can do this the most simple way, which is what I would suggest to you. This is a number, I'm going to plug it into my calculator. Then I'm going to divide both sides by 1/4. Then I would switch it to log form. Evaluate the log, divide both sides by 3 equals 1/3. Alright, this one I think is really complicated. I would put this side in y1, this side in y2, or use Desmos and find the intersection. That's the easiest way to do it. Or you can go back and watch those videos on how to do it. You should get negative 5 over 17. Alright, so you can go back and watch the videos on how we did this. I would add 4 to the other side, and then I would switch it to log form. Evaluate the log, and I'm going to divide by 3. So this will give you 0.4579. For this one, you want to isolate the e. So I would add 5 to the other side first. Then I would divide by negative 6. Remember, to get rid of an e, you're going to ln both sides. When that happens, this cancels out. And then the last thing I'm going to do is add 2. So you should get 5.1427. Moving on. Alright, so for 37, it says continuous exponential growth. That's how I knew to use that formula that I wrote. So it will look like this. This is what you started with. You would change your percentage to a decimal. And when you put this in your calculator, you're going to get this. Number 18, it says continuous exponential decay, so the r is just negative, but it works the same way. So we're going to start with this amount of money, E. I'm going to change, I'm looking for E, sorry. It's going to equal 35,000. So I'm going to divide both sides by 62,000, blah, blah, blah. E to the 5r equals, I'm going to take the natural log of both sides, so I get 5r equals this, and then I would divide both sides by 5. And remember that this is a percentage, so I'm going to change it back to percent. The last one's easier because they actually give you the formula. All you have to know is that you're replacing f of t with 150. Alright, I'm going to multiply that quantity to the other side. $350. And then I'm going to divide both sides by 150. Alright, I'm running out of time, so, and then I would solve it, and I'm going to get 15.69, or 16 days. If you need help on that, just let me know. The last thing we did was nonlinear regression. So you should already know how to do these calculator steps. So for number 41, this is what you should get for the model. And then we just read the problem, and it wants us to do this. And then you would solve. When you solve, you should get 15.53 or 16 years. For 42, I want you to find a logarithmic model. This is the model you should get when you do it. And then by reading the question, we should know to replace x with 20. And when you do that, you get 268.26, or you could have said 268 memberships. All right. So you have lots of videos to study with. You have people in your class. You have me as a resource. Make sure you know how to do the stuff before you begin the test. That's the whole point of this. All right. Good luck.